All right, guys, so let's start talking about some of the real world scenarios and how they relate to your exam. So don't be surprised if you see something similar in your exam. If you listen to all of these stories and understand them, immerse yourself with them, there's no reason why you should not be able to take care of this exam. It's not very difficult if you follow AWS's guide, what they want you to know. They basically AWS wants you to know the real world use cases as well. So I'm hoping that with my 30 years of experience spanning, working for companies like AT&T, Cisco, Fortinet, supporting companies like, organizations like United Nations, Coca-Cola, Citibank, Goldman Sachs in my 30 years career. Things that I've picked up, I want to share those with you, and I have tied them to the exam questions that you would be getting. Okay. With that said, let's move on to the first scenario. So what are we thinking about in this scenario? Customer churn, right? So it's a long story. I'll try to make it short for you so that you could remember it. The main idea here is that, look, when you're a large company, you have to figure out how much does it cost you, or even when you're a small company, you need to determine how much does it cost you to acquire a new customer. Okay, once you have that customer, how much does it cost you to retain one? And what happens if you lose a customer? What is the value of it, right? So you need to understand the value of that customer contact as well. So in this scenario, what I'm thinking, I supporting a telecom provider, and we faced an interesting challenge with predicting customer churn. So our initial team meeting sparked a debate about model accuracy versus business impact. Okay. Some argued that we should optimize for avoiding false positives to prevent annoying loyal customers. No, we don't want to annoy loyal customers with retention offers, right? So, however, our customer success team started, they had the data, so they shared that missing potential churns, or missing the false negative, if we think of missing someone who is about to leave, was actually costing the company far more, right? So each lost customer meant about $1,000 in annual revenue. When we saw our model had 86% accuracy with lower cost for false negatives and false positive, it made perfect sense to deploy it. But the real win was that even if we incorrectly flagged some loyal customers, the cost of retention offers was minimal compared to losing high value customers. Do you get that? I mean, you need to make that. That's a business decision, right? But that's a business decision that when someone is making, you need to implement it. Okay. That, hey, look. I would rather not lose $1,000 revenue over a year. I may give somebody by mistake $100 extra coupon. Okay. That's basically what it boils down to. Great. So remember that. I mean, if you have a situation scenario like that, you would know what your solution should be. Okay. All right, moving on. So there's another interesting scenario from a manufacturing client. Okay, they had this massive data lake in S3 with both structured and unstructured data. Okay, everything from machine logs to quality inspection reports. I mean, anything any machine that did any kind of an exhaust, they ingested it. Okay, everything from machine logs, quality inspection reports. The data scientists were spending hours writing complex code to query this data. Okay, someone suggested moving everything to Redshift. It's a great product. I mean, I would have recommended that too, but it is an overkill. Okay, it would have been an overkill just to solve this problem. Another team members pushed for using EMR, but that would have required managing clusters, right? We didn't want to manage clusters either. So the breakthrough came when we implemented AWS Glue to catalog the data and use Athena for SQL queries. Okay, it was almost comical how something that used to take days of coding could now be done with a simple SQL query. Right. The best part, Their team started analyzing data immediately, without waiting for IT to provision resources. So in this scenario, I think the message that you should take home would be that in a situation, you need to figure out if is Redshift does make sense or not, right? Do you want to manage clusters or not? Or sometimes AWS has very elegant solution like AWS Glue, right? To catalog the data, right? So we need to remember that. And Athena for SQL queries. All right. All right. So the next story that I want to share with you is of training a data set size. Okay. So I remember tackling this exact problem with a video recommendation project. Okay. The team had millions of user interactions, data points in S3, and our first system was pretty naive, right? We tried to load everything into a SageMaker notebook instance. Of course, the 5 GB EBS volume would filled up immediately, right? So one developer suggested increasing the EBS volume size, but that would have been expensive and inefficient. Another wanted to downsample the data, but that would have hurt the model accuracy, right? So the elegant solution was to use pipe input mode. We could verify our training code with a small subset locally, then scale up the full data set without worrying about its storage. Does it make sense? Yeah. It was a great lesson in how the right AWS feature can solve what seems like a major infrastructure problem. So I hope you're getting this story here. That look, in the previous scenario, an AWS product, AWS Glue with Athena for SQL, came to our rescue. In this scenario, training data set size scenario, a feature, we used pipe input mode in S3, and that was the solution enough. All right, moving on to custom pronunciation, right? So how do you we had a challenge at a tech company where their documentation team was using Amazon Poly to convert technical documents to audio, right? So the problem was their product names and acronyms sounded completely wrong. I'm sure you've heard it, right? When you do an ask, computer devices to read something, so they will read, instead of saying SQL, they'll pronounce it SQL. So someone suggested, that we rewrite the documents to spell everything phonetically, right? But that would have made the text look unprofessional. Another suggestion was to use SSML tags everywhere, but that would have been a maintenance nightmare, right? So if you have SSML tags, well, how are you going to manage it? So the right solution was creating a pronunciation lexicon. So we built a simple dictionary of company terms with their correct pronunciation, and suddenly everything sounded perfect. It was a great reminder that sometimes the simplest solution is the most maintainable. All right, so let's talk about dataset repository design, okay? During a healthcare analytics project, we faced a fascinating challenge with storing training datasets. The data science team was creating new datasets daily as they refined their feature engineering, right? At first, someone suggested using EBS volumes attached to EC2, which seemed reasonable until we calculated the cost of storing multiple versions of large datasets. Another team member pushed for using DynamoDB, thinking the fast access would be beneficial. But the breakthrough came when we realized Amazon S3 was perfect for this. It is scaled automatically, was cost effective, and we could use SQL with Athena when we needed, right? The best part was watching the team's productivity soar once they could version their datasets easily. Okay. Now, the time series data processing, again, is an interesting topic, right? This reminds me of a project with a manufacturing client who needed to analyze sensor data in real time. Okay. So their initial approach was to build a custom solution using EC2 instances to process the data, but it was becoming a nightmare to manage, right? Someone suggested using Apache Kafka or EC2, but that meant managing infrastructure. That epiphany moment came when we implemented Kinesis data firehose with Lambda transformation. It was almost magical. Data flowed from their sensors straight to S3 with all the necessary transformations happening automatically. The best validation? Their DevOps team finally got a full night's sleep. Okay. Data movement and transformation. Let's think about that. So here's a fun story from a retail project. The team needed to handle both real-time inventory updates and hourly batch processing of sales data. Initially, they wanted to use just Lambda functions for everything, creating a complex web of triggers and schedules. Others suggested using only batch processing with EMR to simplify the architecture. The winning solution? A hybrid approach using Amazon Kinesis for real-time data and AWS pipeline for the hourly batch jobs. Okay, so think about what we did, right? A hybrid approach using Kinesis for real-time data and AWS data pipeline for the hourly batch jobs. It was like watching a well choreographed dance. Real-time data flowed smoothly while batch processes can run efficiently in their own time. All right, here's another one about video, right? Video security analysis. So working with a security company on real video analytics was eye-opening, right? Pretty much every engagement has been interesting and a place for me to learn something, right? So they started by trying to process everything on edge devices, which quickly became overwhelming, right? Some team members wanted to upload all video to S3 first and then process it, missing the real-time requirement entirely, right? Again, the game changer was using Kinesis video streams with Amazon Recognition. The Recognition is another product. We'll be talking about it later on. But yeah, so we setting up RTSP streams through Kinesis. We could detect non-employees instantly. It was like giving the security team superpowers. They could monitor thousands of cameras in real time with AI assistance.